So we've got a problem here that involves some geometry, a rectangle. So let's draw ourselves a rectangle. Any rectangle will do. And let's start to label. So what we know when I read this is the length of the rectangle is 4 feet shorter than 5 times the width. So the one that comes second, the length comes first, the width comes second. So I'm likely to let x equal the width. And in this case, if I do that, right, if we let x equal the width, then you know that the length is 4 feet shorter than 5 times the width. Now here's that shorter than business again. And we know that what comes after the word than, that's where you start. So I'm going to start with 5 times the width. I'm going to write it like this, 5x, and then 4 feet shorter. So I'll subtract off 4 feet. So our width is going to be x, and the length is 5 times that, but 4 feet less. Now, we know a fact from geometry. We know from geometry that the area of a rectangle is the length times the width, and we're given that the area is 33 square feet. The length, we just wrote that as 5x minus 4 times the width, which is x. Let's multiply through, distribute, we'll get 33 equals, now distribute that x all the way through, we'll get 5x squared minus 4x. This is quadratic, so let's set it equal to 0. Let's subtract 33 from both sides. So we're going to get 0 equals 5x squared minus 4x minus 33. So let's hope we can factor this. We'll get 0 equals, let's set up our parentheses. How about 5x and x, the only way to get a 5, and a 33. I don't think 33 and 1 is going to help, but 11 and 3 will. And I don't think I want the 11 over here because then I get 55, way too big compared to that 4. So why don't we put the 11 here and the 3 here. That looks good. That'll give us a 15 and an 11, which we can get a 4 out of. Let's just get the sign right. This 33 is negative, so the 11 and 3 have opposite signs. And I'll put that middle negative sign with the bigger of these two products. Now, the way I wrote mine, the outer product is 15x. The inner product is smaller, only 11x. So let's put that negative 4 right over here with that negative 3. That'll give us with a negative 15. So we'll put the negative here, the positive here, and that will give us that x equals negative 11 over 5 and 3. So this is a word problem, so we always have to go back and check what x is. So let's follow it all the way back up to the beginning, all the way back up here. X is the width of this rectangle. Now look at our values we got. We got a negative number, so x cannot possibly equal a negative number, so we'll cross that one out. So let's just summarize then. What we're going to have here, I'll do it right up here. The length of this rectangle turns out to be 11 feet, and the width turns out to be 3 feet. And sure enough, if we check this, the area is the length times the width. 11 times 3 is 33. We have it. Problem 18 is a work problem, and we'll solve it this way. We've got person A can do this job in 8 hours, and person B, working alone, can do the same job in 6 hours. Now, if you put these together as one person, how long would it take them to complete the job? So what we're going to do is we're going to let that be x. That'll be our x. So what we're going to do is let x equal, so we're going to let x equal the number of hours working together to complete the job. It's amazing how that just showed up, isn't it? So let x equal the number of hours working together to complete the job. Now, this person A can complete the job in 8 hours. So convert to 1 hour. If it takes 8 hours to complete the entire job, then in 1 hour, A can complete 1/8 of the job. So in 1 hour, A can complete 1/8 of the job. Does that make sense? Let's just look at this. Suppose we have this. All right, here's the 8 hours. A takes 8 hours to complete the job, but in 1 hour, just in 1 hour, A can complete 1/8 of the job. So A's contribution is going to be, for 1 hour, is 1/8. Now we're getting help from B, and B can complete the job alone in 6 hours. So in 6 hours, the whole job is done, but in 1 hour, B can complete 1/6 of the entire job. And now, if these two people are working together, it takes them X hours, right? That's what we did up here. We let X equal the number of hours working together. That's what we have here. They're working together. It takes X hours to complete the whole job. So like back up here, if that took X hours, in 1 hour, they can complete 1/x of the job. There's our equation. We got fractions. We know how to solve them. Let's get the LCD, which is between 8 and 6 is 24 and an x. And we'll multiply every term up here by 24x. 24x times 1 over 8 plus 24x times 1 over 6 equals 24x times 1 over x. Now here, the 8 will go into 24 3 times, and we're left with 3x times 1, which is 3x, plus, and now here, 6 will go into 24 4 times, and we are left with 4x times 1, so we'll get a 4x there. And then over here, the x's will cancel, and we're left with 24 times 1, which is 24. And then on the left side, we'll get 7x equals 24. Divide by 7, we'll get x equals 24 over 7. And again, because it's a word problem, I'm going to go all the way back to the beginning to see what x was. So all the way up here, x is the number of hours it takes to complete a job. This is an odd way to write it. So why don't we write it, instead of as an improper fraction, let's write it as a mixed number. So 7 will go into 24 3 times. That'll give us 21 with remainder 3. So let's write this. X will be equal 3 and 3/7. But we don't include x on our answer. We're asked how long does it take to complete the job. It doesn't take x equals 3 and 3/7. It just takes 3 and 3/7 hours to complete this job.